Hello everyone. Let's discuss this question which I have recently put up in the Chem Media community forum. Number of non-bonded electrons on carbon in hydrogen isocyanide is how many? Only 2 students have answered correctly for this question. Many of them have a confusion about this question. Whenever a question like this is asked, the very first thing you should do is how to write the best Lewis structure. That's what you should think about. How many valence electrons do we have? Hydrogen, we have 1 valence electron. Atomic number is 1. Nitrogen, we have 5 valence electrons. Atomic number is 7, but we are ignoring the 1s2 core because that is a period 2 element. For hydrogen, we don't ignore any electron. There we count the 1s1 electron. But when it comes to nitrogen, we ignore the 1s2 because that is the core. Carbon, we have 4 valence electrons. Atomic number is 6. Therefore, together we have 10 valence electrons. Using 10 valence electrons, let us write the best Lewis structure for hydrogen isocyanide. By the way, hydrogen isocyanide is a high energy isomer of hydrogen cyanide. This is the low energy isomer. Hydrogen isocyanide is a high energy isomer. However, this is found in the interstellar medium. That's why I had asked this question. It is found in carbon rich star like CW Leonis. This is just a side story for you. If you want to Google more about CW Leonis, you can find more info. It is either called as CW Leonis or IRC plus 10216. I still work on molecules related to interstellar medium, so that's why I do know few details about this. CW Leonis is the closest carbon rich star from Earth, but that is 310 light years away approximately. Anyway, that is the side story. Let's come to the main story. So using 10 valence electrons, we have to write the best Lewis structure for hydrogen isocyanide. Hydrogen always comes at the end, and then here nitrogen comes at the center, even though it is more electronegative than carbon. Because it is a high energy isomer, we have to put nitrogen at the center, and then carbon comes at the end. Let's put 2 valence electrons to make one bond between hydrogen and nitrogen. Let's put 2 electrons to make another bond pair between nitrogen and carbon. We still have 6 more valence electrons because total we had 10 valence electrons. Let's put 2 around nitrogen. If we do that, then nitrogen satisfies the octet configuration, isn't it? We have 8 electrons around nitrogen. Hydrogen can only accept duets, so therefore we have 2 here. We still have 2 more valence electrons. Let's put that on top of carbon. Now carbon has only 4 electrons around it. It is not satisfying the octet configuration. We have to make sure that all the period 2 elements do satisfy the octet configuration when we write the best Lewis structure. So therefore, push 2 lone pairs to the bond pair. If we do that, then hydrogen, 1 bond pair, nitrogen, and then 3 bond pair, that means 6 electrons, and then carbon, and then 2 non-bonded electrons on carbon. Now both the period 2 atoms satisfy the octet configuration, isn't it? We have 8 electrons around nitrogen, 8 electrons around carbon, 2 electrons around hydrogen, because hydrogen can only have a maximum of 2 electrons. So therefore this is the best Lewis structure. So in the best Lewis structure, we have 2 non-bonded electrons, isn't it? So therefore 2 is our correct answer. You can also check the formal charges. What would be the formal charge for nitrogen and carbon here? Let's do that. Now we know that formal charge is equal to number of valence electrons in the atom minus number of non-bonded electrons in the molecule, that is number of lone pairs of electrons, not number of lone pairs, number of lone pairs of electrons minus number of bond pairs of electrons by 2. So therefore for nitrogen it would be 5 minus, we have no lone pairs, therefore 0, minus we have 4 bonds, so therefore 8 by 2, which means it is plus 1. So the formal charge on nitrogen is plus 1. How about carbon? For carbon it would be 4 minus 2, because we have one lone pair that has 2 electrons. This is the one, minus we have 3 bonds, therefore 6 by 2, which means 2 minus 3. So therefore minus 1. Therefore minus 1 on carbon. We know that in a neutral molecule, if we sum up all the formal charges, it would be 0. So in this case, it is 0. If we calculate the formal charge for hydrogen, we will get 0, isn't it? Let's do that. For hydrogen, number of valence electrons in the atom is 1, minus we don't have any lone pairs, minus 1 bond is there, therefore 2 by 2, which means formal charge on hydrogen is 0. So if we sum up all the formal charges, we are getting 0. So therefore this is indeed the best Lewis structure. Now let me show the quiz results. Only 2 students out of 17 picked the correct answer. This is not a difficult question at all. As I mentioned repeatedly, if you have a problem in calculating formal charges or writing the best Lewis structure for a molecule, you will do very badly for most of the questions related to chemical bonding. Therefore, you need to get your grip on these topics. This is very fundamental. You can't make mistakes on questions like this.